Good morning, good afternoon, good evening. This is Mr. Payne bringing you Unit 8, Lesson 4. Objective. You will be able to complete the square and identify the vertex from your answer. The turning point of a parabola and its general shape are relatively easy to determine if the quadratic function is written in a shifted or vertex form. Review this first exercise. I want to make sure that you recognize some words that we've seen repeatedly now. So let me just get a good highlighter here. The turning point, you've seen that now repeated. Vertex form is a new word for you, but it's this right here. This is my vertex form. This is what it looks like. And we discovered and created that yesterday, or the video before. Today we're going to expand that, and we're going to complete the square to make sure that everything looks like that, so that it's easy for you to understand how to shift it and what it looks like, and determine if it's going to be a min or a max. Let's go ahead and look at exercise number 1. Given the function y equals x minus 3 squared plus 2, do the following. Given the coordinates of the turning point. Well, don't forget, inside my parentheses, I'm going to go left or right. This is telling me that I'm going to go right 3. So I'm going to go to a positive 3, and I'm going to go up 2. So therefore, my coordinates are 3, 2. Determine the range by drawing a rough sketch. So if I have my y-axis, my x-axis, and I go to 3, 2, 1, 2, 3, 1, 2, my vertex is there. Because it is a positive coefficient, I'm going to open upward. Therefore, my range is starting at 2, and that's going to be boxing because it's including 2, and it's going to go up to infinity. The question then is how we take a quadratic of form y equals ax squared plus bx plus c and put it into the shifted form. This procedure is known as completing the square, but it needs some additional review. So exercise number 2 is review from the past. Write each of the following as an equivalent trinomial. So x plus 5 squared. Really what that means is that I have x plus 5 times x plus 5. You can complete that multiple ways. You can complete that by double distribution or the box method. I'm going to go ahead and complete the box method. This is review, and you guys are getting really good at this, so this should not take us long at all. I have x times x, which gives me x squared. 5 times x is 5x. X times 5 is 5x. 5 times 5 is 25. At this point in time, we're mastering the skill. So I have x squared plus 10x plus 25. This is not new. What I do want you to recognize are a couple things. I want you to recognize that if I take 5 plus 5, it gives me the 10. And if I say 5 times 5, it gives me the 25. Let's just pay attention to that. Let's do b and make sure that same thing works. So I'm going to do b again. I'm going to say x minus 1 squared is x minus 1 times x minus 1. I'm going to complete the square. The box method, x minus 1, just to verify everything that we have found. Negative 1 times negative 1 is a positive 1. So let's check this out. Simplify that. X squared minus 2x plus 1. Well, was I true? Negative 1 plus negative 1 gave me negative 2x. Negative 1 times negative 1 gives me a positive 1. So now, I shouldn't even have to complete a box for c. You guys should be getting good enough that I can say, alright, x times x gives me x squared. 4 plus 4 gives me 8x. And 4 times 4 gives me 16. I think that all of us are good enough and strong enough to pick up on those little hints. Let's go to exercise number 3 quickly. Given each trinomial in exercise 2 of the form x squared plus bx plus c, what is true about the relationship between the value of b and the value of c? Let's illustrate it. Well, if I take b and I cut that in half, and then I square it, that will give me c. Let's try. So if I take 8, divide that in half, and square it, what will I get? Well, what is 8 divided by 2? It's 4. 4 squared equals 16. Is that not 16? Yes, it is. So this holds true for every case. Exercise number 4. Each of the following trinomials is a perfect square. Write in factored or perfect square form. What I want you to talk about here is that we've done perfect squares before, so it's not going to be new to you. This is not difference though, so it's a little different. I have x and x, plus and plus, because I want to say what times what gives me 100 adds to give me 20. It's 10 and 10. How else can I write that? I can write that as x plus 10 squared. Let's take a look at b. I have a equals 1, so I've got 2 parentheses. X and x minus minus. What times what gives me 9 adds to give me 6, and that's going to give me 3 and 3. How can I write that a little easier? X minus 3 squared. Last one, let's try together. I have a equals 1 here, so I can go ahead and do my 2 parentheses. I have x and x, plus and plus. What times what gives me 1? 1 and 1. How can I write that a little simpler? X plus 1 squared. We are finally ready to learn the method completing the square. This method has many uses, but the one we will work with today is manipulating equations of quadratics from standard form to their vertex form. There's that word again, vertex form. It helps me put the quadratic into, or identify the quadratic's vertex very easily. So, the quadratic y equals x squared minus 4x minus 1 is shown below. Consider only the binomial x squared minus 4x. What would you need to add on to it to create a perfect square trinomial? Well, think about that real quick. If I figured out and use what I just learned in exercise number 3, I would take my b, which is 4, and I say 4 squared, or I'm sorry, 4 divided by 2 squared, and that will give me my c. 4 divided by 2 is 2. 2 squared equals 4. So what would I have to add to create a perfect square? I would have to add 4. In order to add 0 to the binomial x squared minus 4x, what should we subtract to offset adding 4 to make it a perfect square? We should subtract 4, so it'll look like this. X squared minus 4x plus 4, because we said we added it. Now we're going to subtract that plus 4, because we really want this section here to be 0. Then I'm going to go ahead and put the minus 1 back into the equation. It says, use the method of completing square now to rewrite the binomial x squared minus 4x minus 1 in an equivalent shifted form. According to this form, what are the coordinates of the vertex? Verify by examining the graph. So I'm going to rewrite it real quick. I have x squared minus 4x plus 4 minus 4 minus 1. This minus 1 is from the original problem. This plus 4 minus 4 really give me 0. Okay, that's my 0 pair. So this guy here is imaginary. But what I want to make sure that you understand is that I'm now going to factor x squared minus 4x plus 4. And what you're going to notice is that I have 2 parentheses. I have x and x minus minus 2, 2. How could I write that in a simpler form? I can write it as x minus 2 squared. Now all I have to do is go ahead and simplify this part. Negative 4 minus 1 is going to give me a negative 5. Now I have written it in vertex form. If I want to determine what my vertex is, remember I'm going to go right 2, down 5. right 2, down 5. So that's going to give me a positive 2, negative 5. Let's check our work with this right here. Did I go negative 2, down 5? Yes, I did. So therefore, my vertex matches my picture. We did it correctly. Let's take a look at A. I'm going to do A, B, and E with you. You're going to do C, D, and F on your own. A. I'm going to take my B, which is 6. I'm going to divide it by 2, and I'm going to square it. 6 divided by 2 is 3. 3 squared is 9. So I'm going to say y equals x squared plus 6x plus 9. Now in red I'm going to show you what I'm subtracting. Minus 9 and then minus 2. Don't forget that my pair here in the middle is my 0 pair. So now let's go ahead and factor this. I'm going to say that part right there, let's factor it. I'm going to say 2 parentheses x and x, plus and plus, 3 and 3. How can I write that easier? I can say x plus 3 squared. Now let's simplify negative 9 minus 2, which is going to give me a negative 11. What is my vertex? My vertex is left 3, so it's going to be negative 3, down 11. And so there's my vertex. Remember that this is opposite here. I know it says plus 3, but we're really going to move it to the left 3. Let's do B. My B is negative 2. Okay, so it's just 2 divided by 2 squared. 2 divided by 2 is 1. 1 squared is 1. I have x squared minus 2x plus 1. If I add 1, that means I have to subtract 1 plus 11. I'm going to go ahead and factor that pair there. I have x and x minus minus. What times 1 gives me 1? What times what gives me 1 adds to give me 2. 1 and 1 subtracts or multiplies to give me 1, adds to give me 2. How else can I write that? X minus 1 squared. Now I have to simplify negative 11 or negative 1 plus 11, which gives me a positive 10. What is my vertex? My vertex is positive 1, positive 10. Go ahead and hit pause and complete C. We'll check that over in class. Let's take a look at D, E, and F. I'm going to do E with you. You're going to do D and F on your own and be ready for class. So let's take a look at E. I have 5 divided by 2, because that's my B, squared. 5 divided by 2 is 2.5 squared, which gives me 6.25. So I have x squared plus 5x plus 6.25. If I add 6.25, that means I have to subtract 6.25 because I want that 0 there. And then I'm going to subtract 4. I'm going to go ahead and factor this. I know that if I 2.5 squared is 6.25. If I take the square root of that, it's going to give me 2.5 back. So I'm going to have x squared plus 2.5. I'm sorry, not x squared. X plus 2.5 and x plus 2.5. How can I write that a little simpler? I could say x plus 2.5 squared because I have 2 of them. Now I have to go ahead and simplify my negative 6.25 minus my 4, which is going to give me negative 10.25. So what is my vertex? It's left 2.5, so that means negative 2.5, comma, negative 10.25. I know it's a little bit more complicated because we're dealing with decimals, but it's the same concept.